Welcome to Enots Engineering. I'm Alan. In this episode we heat treat some components, do some milling in the lathe, make the grinding wheel arbor, and in the second half wire and test the electric motor. So let's get into the workshop. I've taken the tool holder apart, and the parts that you handle a lot I'm just heat treating on a gas hob. I've got a steel dish, and inside the dish are the parts I want to heat treat. I've also got some brass cuttings and filings which will hold the heating around the components. As each component turns blue, I'd remove it from the heat and let it cool down. It's important, if you decide to do this, to use a steel dish, as an aluminium dish may start to melt. This took about 15 minutes to heat treat the components. You can see the difference between the treated and the untreated parts, and I'm hoping that the bluing effect on the graduated thimble will show the graduations up more when they're cut. We'll now start to make the final part of the tool holder, and this is the part that holds lathe tools. The next job is to mark a line 3/4 up from the bottom. So I've got a small surface plate and this height gauge, which is a digital height gauge. Set it to 0 on the plate, just bring it up to 3/4 the line, and get the centre the other way. Okay, I've set up my boring bar. I come in, touch the face, move to the centre, lock the saddle. So I'm going to use the top slide just to go in and bore this out. Explain what I've done. Because I've got a mill slot in here all the way around, I've put the milling cutter in the chuck. This is an end mill. I've taken the tool post off, used the tool post bolt and nut, packed up this side, packed up the part so I get it to the right height, and then use the clamp strip across the top to hold it in position. I've clocked the front of the part up so I know it's parallel with the cutter. Because there's a bit of backlash in this cross slide, I've tightened the jib strips up so that it takes out any sudden movement. I'm running this cutter at about 210 RPM. Here's the finished milled part. All that needs doing now is drilling and tapping. This is the finished tool holder for lathe tools. This bar is eccentric and goes in the back. 1/8 pin holds it in. These are the complete set of parts that make up the cutter grinder tool holder for various size tools. I've marked the circumference of the pitch circle that I want, and I've stepped off 3 intersections with the dividers, and now what I'm going to do is centre drill each one, drill. This is the grinding wheel holder. We've just drilled the 3 holes. The way I did that was machine that first, made a small hole, made a spigot on the other part, drilled and tapped a hole and bolted that to it. Then put this whole unit on the drilling machine and drilled the 3 holes and counterbored them roughly on that face. All I need to do to this is finish the counter boring off, which I can do on the drilling machine with an end mill. The next job is to turn the spigot on here and face this little spigot off, reduce the diameter and bore the hole to fit the electric motor. This is the cup wheel that the arbor's for. That's a reasonable fit on there. It's not tight, but it's not loose. So I'll leave that. It's just a couple of thou oversize, that is. The next job is to bore an 11mm hole to suit the motor spindle. Just changed tool to take the corner out so that the other tool left in. Just remove, make it a nice sharp corner. Now, as per the instructions that come with the kit, I've made a bar that's 11mm and it's just got a slight step on the end, so when that starts to fit there I know I'm near the size for the motor. I've set up my small boring bar. I'm a bit concerned about the amount that it's only small, and I think that may flex. It's overhanging. Set the feed to 0.3 of a millimetre per rev. There it goes. I've also set a clock on the carriage dial indicator. It gives me a warning of when I'm coming close, and I've got 6 turns to 0. Okay, I've set my 3-jaw chuck up, changed the jaws, clocked up the job. It's running to about 0.01. Ready to face this to thickness. Just skim this down. That'll do. I've just put chamfer on the corner, deburr the hole, and that's ready for drilling and tapping. What I'm doing now is just lining up on the previous hole I drilled with a 9mm drill. So I've put the 9mm drill back in, just feed it, and you can see the drill's kicking over. So with the cross slide I can move it until the drill goes in the hole without kicking. Turn it 90 degrees because of the flutes in the drill will give you a sharper edge on each side, and then do the next axis, y-axis, so it goes in without any resistance. Let's turn it back. You can see there's no resistance here, so I know now that that drill is centered on that hole. So I can change it. What I'm doing is putting a 10mm end mill in to give me a flat bottom and the depth of the hole for an Allen screw head. So there's one I did before, that one I've done, so it's just this one to square the bottom off. Okay, I've taken out the 4 screws off the top and take the lid off. Inside we've got a capacitor, which is, take the gasket off, we've got a capacitor which is wrapped in this. Now the first job is to remove the capacitor and these link bars. So what I want to do first is to put a piece of tissue paper down in the hole there at the bottom of the motor. This is so if any of these washers fall, they won't end up inside the motor. Remove all the cables from the posts and take any straps off. What I'm looking for are the two coils and an earth, and by the look of it, the two red ones and the two blue ones should be the two coils, and here's the earth connection. So what I've done is put the test meter on ohms. I'll just connect one lead to the blue terminal there and the other lead to the blue terminal. That's giving me a reading of 21.4. They're the same with the red. And that's giving me 14. So the higher resistance is on the blue terminal, which means that's the starter winding. And on the instructions, it's actually matches up with this motor because they've got them in red and blue, the same as the terminals. I'll thread the wire through the gland, and on the end of each wire I've fixed the terminal connection, red being the red coil, blue being the blue coil, and the odd one then is the earth. I didn't have a yellow terminal there, so it's a blue one. So all I've got to do now is fit the blue and the reds together, and that's the motor wired up at this end. Right, so just double check. We've got the coil, the blue coil, which is the starter winding, going to the grey wire. We've got the other side of the starter winding going to the black wire. We've got the main winding, one side going to the blue wire, and the other side of the main winding going to the brown wire. And then the fifth wire is the earth connection, which goes to the earth. So the wiring in here now is finished. We can put the lid on, put the gland nut on, and start on the other end. Right, I've just got some 3/4 flex. The first thing I've done is put a 3-pin plug on and putting in a 5 amp fuse. So I know this end's finished. Put the cover on. The moment we've done the electric motor fittings, fitted the 5-core cable, and now we're going to do the rotary switch and the 3-pin plug, and that's the connector block which is there, and we put the capacitor in and the rotary switch, which looks like that, with the terminals are marked up on here. Forward, reverse. I've taken some time to wire the switch. It's not complicated, but you need to double check that you've got everything right. You have to put some bridging links in, the 5 wires from the motor, and the capacitor's fitted up to that. So I've just switched the power on and nothing's happened, there's no smoke, so that looks promising. Now this is the switch. Turn it forward, the motor's going forward, off, put it in reverse, and the motor's going in reverse. So everything's working correctly. Now the next job is to remove some of the parts, bolt the motor to the casing, and fit the glands to the motor housing. I fitted all the parts into the plinth, put the wires through the glands and fitted the switch to the side. I fitted the motor to the plinth. I've used a piece of rubber, which is a sheet of pond liner actually, roughly cut it, bolted it down, checked the earth has a contact on the metal, both sides, the motor and the plate at the bottom, so I know the earth is continuous. I've also made a small, well, I found a small block of aluminium with a hole in, made a little cable clamp there and screwed it in one of these holes, 6mm holes. The motor and plinth have been fitted to the base and the rear cover put on the electrics. As you can see, the grinding wheel guard has just been placed there ready for painting, and the table is fully assembled. Here's a way of checking the table. On your mobile phone, just download an app, it's usually spirit level. You put that on your table, you can zero it there, and then as you adjust your table, you can set it to whatever degree you need for marking the degrees on the end here. So you can use this as an accurate way of setting the degrees. It's a free app, simple, or you could turn it to a bubble app to make it level on your table or bench. Now that's the machine virtually finished. I've got two jobs to do. One is to mark the degrees here, and the other is to mark the size on the thimble here. But that'll be done on the CNC machine. So basically the machine's finished. I have got a diamond grinding wheel, which I'm thinking of maybe trying to get it to fit on here by making the bore bigger in this.